Today we are going to discuss a new topic known as aromaticity. So, we're going to discuss aromaticity. Now, just before starting and highlighting the various conditions of aromaticity, let us just see that a point that I need to highlight is that compounds like benzene, we all know that benzene is aromatic and its structure looks something like this. So, compounds like benzene show aromaticity. We all are aware of this. And what happens is their resonance energy, because of this aromaticity, their resonance energy increases and they resist addition. So, they have a high resonance energy because of aromaticity, and this due to this they resist addition. They resist addition and are highly stable. So if I connect all the dots here, because they're highly stable, they're highly stable, they resist addition because they don't need any reaction now to make them more stable. So they resist addition because, and they're stable because of their high resonance energy. So these are three things which happens when any compound becomes aromatic. So let us see which compounds are aromatic and which are not. So there are some conditions that aromatic compounds follow. So conditions to be aromatic. Now there are some conditions which need to be followed. There are some conditions which need to be followed to become aromatic. Now, three conditions that you have to be aware of is that first is they have to follow Huckel's rule. Now, what is Huckel's rule? That is, they have to have 4n plus 2 pi electrons. And here, the n is a whole number, or to put it more simply, n is starting from 0 and continuing all the way up. So they have to follow the Huckel's rule, that is 4n plus 2 pi electrons. Secondly, they should be planar. That is, they should be sp2 hybridized, but not sp3. Please keep that in mind. And the third one, which is important, is that they should be cyclic. So they all should follow three things that we want them to follow so that they become aromatic is that the first one is that they should follow Huckel's rule, second one that they should be planar, and the third one that they should be cyclic. These three conditions, whenever they are met, the compound becomes aromatic. So if I come back to Huckel's rule here, I see that 4n plus 2 pi electrons. So if I just put n as 0, then I get 2 pi electrons. N is 0, 4 into 0 is 0 plus 2 pi electrons. And if I put n as 1, then I get 6 pi electrons. So this is how it continues, the series. Okay. So moving on, let us see some examples on how to make us understand that the conditions to be aromatic are to be seen. So, the first one I have here is benzene. We all know benzene. Before going into the details, let us just remind ourselves that if that we have a pi bond, one of the bond is pi and the other one is sigma. And this pi bond here, this contributes 2 pi electrons to the system. Please keep this in mind before doing anything. Now, we have here the first one, benzene, in front of us. So in benzene, let us first see the first condition, which was Huckel's rule. So we have a pi, so we have a pi bond here, a pi bond here, and a pi bond here. So I can say that we have 2, 2, and 2. So we have 6 pi electron. Now, if I compare it with 4n plus 2 and I put it at 6, we get n is equals to 1. So yes, it follows Huckel's rule. Moving on to the next one. So the first condition is satisfied. Now, moving on to the next one is that it should be planar. Now, let me see. All the carbons are same in benzene. So let us just see their hybridization to make sure that they are planar. So we have to have sp2 hybridization to make them planar. So we have, if I see one carbon here on top, let us just take a carbon here. This has one hydrogen attached to it as to complete its valency. So if I have, let us just say that if there is this present, then it has a sigma bond here, a sigma bond here, and one sigma here. So it has 3 sigma bond, and we can say that it is sp2 hybridized. So just to conclude, what we want is that all carbon are planar here. So this is a planar compound. Now the third condition was that it should be cyclic. Now we can easily see that this here is a cyclic compound. It is very apparent to us that this is cyclic. So all the 3 conditions are followed. First was the Huckel's rule, then was it being planar, and then it was that it should be cyclic. So all 3 conditions are satisfied. So we can say that benzene is aromatic. This is how you see whether a compound is aromatic or not. Now, moving on to the next example that we have here, the second one. Let us begin by considering the Huckel's rule again. So, I have to see whether it follows the Huckel's rule or not. Now, according to the Huckel's rule, we can see that it has one pi bond here, another pi bond here, and a third pi bond here. So it has 3 pi bond that amounts to a total of 6 pi electrons, as we have discussed, and 4n plus 2 gives me 6. So n is equals to 1. So it follows the Huckel's rule. This condition is satisfied, the first one. Coming on to the next one, the second one, we have to see whether it is cyclic or not. Now, we can see that this compound, which is known as hexene, in hexene, I see an open structure. So it is not cyclic. And thus, one of the conditions is failed. We fail to satisfy one of the conditions. Now, what this does is, if any one of the conditions are not met, the compound becomes not aromatic. So this compound is not aromatic. So we can just say that hexene is not aromatic. So this is how we see whether the conditions of aromaticity are fulfilled or not.